All right, so hello everyone. I'm Eric Platow with LexisNexis, and I want to talk to you about taming the web. All right, so these are the topics that we're going to hit today, and what you're going to see is that I'm going to touch on a lot of topics that you might have heard either earlier today or even yesterday. So there's going to be a lot of kind of themes that are interwoven into all of this. So for our project specifically, we were told, okay, we have a seed of information about lawyers, but it's getting a little old and hasn't been touched in a while or has to be maintained manually. So we want to update about 1 million attorneys. Oh, and by the way, you have 6 months to do it. And oh, by the way, you have yourself, an intern, and one other person to get all of this done in 6 months. We had 10 people that were data stewards, but they don't know technology, right? So they knew what they were trying to get to, but they don't have any capability to program. So how do we get to getting all this information off of the web and into our databases to update all that information? So the question is, why? Why did we want to do this? Well, product came and had the bright idea of building an analytical system on all of the legal information out there so they could trend information to say, well, for all these law firms, where are they going? What are they working on? What kind of cases are they taking on? For the attorneys, what kind of cases are they working on and where are they going and what's their win percentage and all that kind of stuff. And to be able to handle any of that stuff, you have to have the foundation of the entities to be able to do this. So if any of this has any kind of inkling of, boy, this is my project is hitting some of this stuff, this is a talk for you. I'm here to try to help you. So I'm going to talk a little bit about how do you get from nothing and starting from the project and what kind of things you're going to have to get through to actually implementing the project, how we implemented it, and how we got the information out. So the very first thing that we had to hit were some guidelines. So we're looking at a lot of information that we've got to collect, much like many of you guys here. And we want to make sure that we can do it repeatably, right? We can't have this be a one-time process. It can't be done by the 10 people that we have that don't know technology. We have to do it monthly. So we have to have the information constantly being refreshed, which also leads us to saying that it has to be automated, right? We can't have anything that's going to be a human-in-the-loop process at this point. To make this happen, we have to automate the entire process. We also have to make it scalable, right? So that way we can handle all these websites, which when we were starting was about 100,000. We've grown to about 200,000 websites that we're crawling. So it has to be able to handle that kind of volume, that kind of speed, so that way we can get all the information out of the websites and into the databases. I talked about the 100,000 websites. It has to be expandable. So we knew that we were hitting the US, and the US was our primary first target. But we also knew that we were going to expand over time to other countries. And we were going to expand to other things besides just law firms. We're going to hit other entities later as well. And oh, by the way, I have a high suspicion that other areas of Lexis, because we're a large company, are going to want to tap into this, right? They're going to want to tap into this capability to scrape websites generically and get the information back. So why not make it unlocked so that other areas of Lexis could come in and say, you know what, here's another 1,000 websites, just go and scrape them. Well, 1,000's like a drop in the bucket to me, right? So yeah, cool, let's do it. So we wanted to make sure that we could reuse it for all these unimaginable ways that we didn't think of at the time. So, the World Wide Web is really the wild, wild west, at least for us, right? When we have to deal with this kind of information from these kind of sources, some of the websites really look like, and I swear, were written in 1993 by a high school kid at the time, right, and never touched again. It still looks like it probably did when it was written in 1993. And then you have the other end of the spectrum, which is these are beautiful websites that are well constructed and well organized, and the information is just pristine, and it looks great, but sometimes they obfuscate the data. Darn those people. Why are they doing that? Or they're going to put bots on it, right? Or they're going to have it be really dynamic and not static information, so it's harder to collect. So we have this vast array of information that we got to deal with in our processing. So as we were starting down this whole path, we noticed a few things as we were trying some websites out. One was some of the websites have multiple languages, and we didn't want to scrape the website for all these different languages because it's the same content, right? It's just in different languages. So we had to figure a way to kind of get around that. Another interesting find that we had, and this one blows my mind, is that they had production websites that pointed to certification environments as well, that pointed to their dev environments. So we were crawling information and picking up their cert data and their development data. And when we started to extract this stuff out, we're like, wait, why is there like Joe Bunny in here, right? Or Mickey Mouse is in here. Why is that? And then when we dug into it, it's like, oh, they've got their test information out there. Whoops, we gotta stop that. And then there's another one, another rabbit hole, and this one was a big one, was as we were scraping and crawling, we're like, why is this site taking so long? It's a like 2-lawyer little website. They shouldn't have that much information. When you look at it, well, they had information on their events and their calendar and their blogs from like 10, 20 years ago. So we were going down all these rabbit holes that we knew when we were processing the data, we didn't want to have to deal with, right? Because that's a ton of information that we're going to collect back, have to process through it just to find the 1 and 2 pages out there that we really cared about. So just as a little forewarning, if you do these generic crawls and generic scrapes, you might run into a couple of these things. So once we got through all that, we had to define some rules. And I'm sure the legal team's going to be really happy about me because I'm starting to talk about some legal stuff here, right? So we have to make sure that we honor terms and conditions of the website. We have to make sure that we're not getting PII information. Now, yes, we were collecting information that was on people. However, this is the business card type information. So this is your email address of your business, your phone number for your business, and not personal stuff that's going to be your residential information. So we were approved for all that. And we had to make sure and prove that we weren't going and getting any copyrighted information. So once we got through that, we got through the first little step of the legal hurdles. Then we talked about other things about well, how do we be a good citizen, right? We don't want to go through and destroy these websites and just hammer them when they were built in 1995, running on probably a Windows 98 machine. We want to make sure that we're being a good corporate citizen with them so that we're not killing their machines and we're honoring the robots.txt. And then we also have some parameters that we can set to say, well, if you spend this much time on the website, you know what, just end. Like, that's enough. We're good. We've got enough information from it. We're probably not going to get anything new, so just stop. And then we have some things where, okay, we found all these blogs, we found all this event information that we don't care about. So we started to get into building out extract pathways or specific strict pathways. And for any given website, we can specify all of those parameters into the information that we're sending over to Zeit for us to get scraped. All right, some more rules. So what do we have to do? So some of the websites will get, the URLs that we have may be older, right, and may get redirected. So you have to figure out what do you want to do with that. In our instance, we said, you know what, don't bother. Tell us about it. That way we know about what, that it's changed, but don't bother scraping it. You have to worry about sites being squatted. So all of a sudden it looked like a lawyer website. It was a lawyer website. All of a sudden it's a Chinese shoe shopping site or something like that, right? And you're getting information back. You have no clue what's really going to come back. Just because it was something one day doesn't mean it's going to always be that same thing. You also have things where the domain gets for sale. They go out of business, so the domain's for sale. It becomes an inappropriate site because it got bought by somebody else and they did something that they really shouldn't be doing. So you're going to hit all kinds of craziness, right? I'm telling you, it's a wild, wild west out there, right? It's crazy. And we're going to have to deal with all that stuff. As well as, sometimes you hit the site and then it goes to a subdomain and you got to figure out what to do with that and if it's good or bad or whatnot. So you got all this crazy stuff that you're going to have to deal with. And if that's not enough, we still have more stuff to even think about, right? So you have CAPTCHA. And okay, well, you hit a site and it's got CAPTCHA. What do you want to do about that? That's a question that you're going to have to make sure you answer. In our instance, we said, you know what, don't worry about it for now. If we want to get there, we'll go, we'll figure it out at a later time. We've got enough information that we're going to be dealing with. Obviously, we talked wildly about anti-bot, so I'm not going to spend much more, but you guys get the picture. If you got to deal with logins for the information we were dealing with, we didn't care about logging into anything. We're really going after the publicly available information, so we didn't have to deal with any logins or passwords or any of that stuff. And then, of course, the request types and headers and all that, which, the anti-bot, which has already been covered for me, so which is awesome. Uh-oh, this did not come out nice. Okay, so if you use your imagination here, this is a little bit of our architecture here, and you can see that everything's kind of split up. And what we did was we took each step and said each step is going to be its own process. So that way we can auto-scale each thing independently, and we can have queues in between each step. So that way, as stuff is backing up or is being processed, right, we can auto-scale one thing, not have it scale another. We can start things as soon as the stuff comes in. So the very first set is a crawl step. So what we do is we partnered with Zeit, and we had Zeit deal with all the crawling. They were the experts in the crawling space, right? I didn't have time in my 6 months with 3 people, one of which was me, to build our own crawler. We tried, right? And we had a cute little crawler. It was nice. It did some pretty things. It worked, right? But in the scale that we were looking at, there's no way we could have possibly handled it. So we partnered with Zeit, and we came up with a process where we hand them a CSV file of all the URLs that we want to go and collect, and they go and collect it for me. What happens then is that they send me back the HTML and the vCards. So I get it back as if I crawled it myself, but I don't have to go and do all that hard work for it, right? So it comes back just as it came from the website. So then the very next step, as soon as that data hits our S3 buckets, is that we are then going to classify the pages. Because when a website comes in, it's got thousands and thousands of pages, potentially. Some of them are just single pages. And you have to classify it to say, is this a page that I care about? So that way I eliminate a lot of processing time and a lot of steps that I don't have to deal with for pages that I really don't care about. Right? So we just knocked off a whole pile of probably about 80% of the website pages out there that we got back. From there, we do our extract. And I'm going to talk about this in a little bit more detail, but you can see 3 different things there. In our extract phase, once we know the pages that we're going to be working with, we can use lists and regex, and that was our first process step to be able to get the information out. We used natural language, so we built our own models to get information out of the websites as well as moving on to LLMs, because why not? Everyone's into LLMs, right? It's a cool, hip thing to do nowadays. So once we've got our data extracted out, we then have to match it, because, again, it's a wild, wild west, so why would anyone say, the name of one entity exactly the same way on another site? For instance, lawyers go to school, they mention their school name. So it could be University of Pennsylvania, it could be UPenn, it could be all kinds of different ways that they spell out their school. And it's all correct, it's all right, but it's not consistent, right? And we want consistent, accurate data. So we had to deal with all of that and do a lot of fuzzy matching to known lists to make sure that we can link it up and get it correct. All right, so now we're like, whew, we're gotten through all that, right? That's awesome, we're ready to roll. Oh, wait, we've got to do matching, right? Fernando was mentioning that just yesterday about how matching is a really hard problem to solve, because we have a person that we just got extracted off of the website. We have a person or many people in our database, and we have to make sure that we have the right person going into the right spot, right? If the same person's in our database, we want to update them. If it's not, we want to create a new person. So the fuzzy matching here is a huge part of this, and was a huge decision tree that we had to build and figure out to say, what do we do with this data? We got the data extracted out. What do we do? Finally, we do our final action. So we do our create, we do our edit, we validate it, and we log it. So what that really allows us to do is to automate the entire editorial process is now automated, the whole thing. Except we have humans go back on the flip side and review what the automated system did. And that final review is really important to make sure that A, you're getting it right, and B, that you've got it right, and if you've gotten it wrong, actually, that you can feed it back into the system and start learning on that. All right, so for our automated data extraction, we had to classify not only that, but the very first step before we even start is to classify the site itself. Is this a site we care about? Is this site still valid? Is this site still there? So we do all of that classification before we send anything out. Then, like I talked about, we classify the pages to get rid of a lot of stuff. We define our data priorities because, not every data point is easy to get to, so we wanted to make sure that, if we got the name was the most important part, and then the email address, so we could contact them if we needed to. Or even like for our customers, as they're looking at the information, can say, oh, well, you know what, we see that, Joe Bunny, lawyer, is really good in this area, in our, area of expertise, in our, jurisdiction, and so that's the person we want to contact and we want to work with. So we had to prioritize what data we were going to extract out, and then we were going to use multiple layers of how we do the extraction. Okay, so if everyone's still with me, now we're going to get into the fun stuff, right? Okay, so this is my cat. This is not a lawyer. This is a sample website page of what one might look like. So my cat does think she's a lawyer, and she does think that she owns a whole household, right? So kitty cat here, she's a partner, Washington, D.C., education, admissions, and et cetera. So the very first thing that we said was, you know what, this is a fairly well laid out HTML page, and there's only so many ways that people could say education, or there's only so many ways that people could say where were they admitted to. So we used regex to find those locations and say, okay, well, once I found the location, it's going to be a list. It's a list somehow, some way. That stuff is a list, right? So we could extract that information to process it without having to have all this advanced capabilities. But this was a nice and easy way for us to get to it. Now, if this information that's off to the right was actually down here in the paragraph of text, that's when it gets challenging, and that's where we said, you know what, we need our machine learning models. So afterwards, after our first round of extractions, we started to build our own machine learning models, right? So we used Spacey and did NER, and we used the PyApp for US addresses, and we used our natural language processing stuff to get all the information out of those paragraphs of text. And you know what? It was a pain in the rear. It's really hard, right? We had data scientists out there that were working on this problem, trying to figure out how to get it, make sure we had annotated data, so that way we knew if we got it right or if we got it wrong. And it takes a lot of time and a lot of effort to do that. So what we ended up doing was we said, okay, well, we're going to send this data and use Bert or Roberta to ask questions of the data to get the answers back. And it was working great. It was really pretty good, but it was slow. It was really freaking slow. We couldn't get all the data out fast enough. So, we went and we kept training the models and retraining it and comparing the data, et cetera, and decided, you know what? Heck with this. We're done. We are done. You know why? Because large language models are coming to the rescue, baby, right? Here we go. They are riding in here on their white horse, and they're going to solve this problem for us. And you know what? It actually has done really, really well. So the very first thing I want to caution you about, though, is using a large language model, make sure you check the terms and agreement about what they can and can't do with the data. There are some LLMs out there that can do whatever they want with the data you send them. So they could use it for marketing, they could use it for their own training and testing, et cetera. So just be cautious about that. So I know everyone's all, chat up and chat this and chat that. There are other models out there, so make sure you do your research to figure out which models are going to work best for your reasons. So what do? So we supply the content to the model and then ask it questions about the data to say, well, are there attorneys on the page? If so, what are the attorneys' names? And where did they go to school, et cetera, et cetera. And the first round of stuff, we send it the data, we ask it a question, we send it the data, ask it a question, and we did, you know what, that's really inefficient. Just because that's the way the old system was doesn't mean that's the way the new system has to be. So we said, you know what, the heck with that. We're going to ask all our questions at once, get all of the data back in JSON format, and that way we don't have any downstream processing changes to make. Amazingly, it did it. I was floored. It did it. I was like, wow, this is pretty cool. So we did another round of prompt engineering, and make sure that when you do your LLMs, you do prompt engineering. Don't just take the first answer that you got back as, yep, we're good to go, we got it, like, let's rock on, we're done. Because you can get better answers just by the way you ask the questions. So make sure you spend the time to double check and retry and re-ask the same question in different ways, right? Because you can get a better answer just by tweaking the question that you have. Another thing I want to give you a warning about is sometimes, so we asked it to get us data in JSON format. But one of the times, well, some things that it has done for us is return us invalid JSON. So you're like, why did you do that? I asked for JSON, this is invalid. Why can't you get that right? So you have to make sure that you double check what it's giving you back. So it can be invalid. If you ask it again, it could be valid the next time around. Or you could say, hey, make sure this is valid, or you can do other tricks to get it there, but just make sure you get valid information back. And finally, an LLM isn't the be-all and end-all, right? It's not everything. It doesn't do everything perfectly. So you got to make sure that you double-check that. So for our scores, we took our 40 hardest data sets to go and extract out and compared our homegrown models to the LLMs. And the LLMs in the orange and the gray far outperform what we built. So after all our tweaking, we were like, this is it. We're really onto something here. And you can see we tried a couple of different models, and the two models, the one was the large model, was way more expensive, only got us a real fraction of an increase in one of the different fields. So why? Like, why? The small one's the way we're going. But you can see here, all this stuff in the middle is all low, meaning that it sucked. It didn't do well for various reasons. Some of the reasons were because we couldn't send them all the tokens, or we stripped off the headers and the footers, or whatever. But we found that for those kind of information, regex was actually better. Regex is cheap. Regex is fast, right? So why use LLMs just because it's a nail sitting there? You don't have to use your gargantuan hammer all the time. So make sure you think about that as well. So once we got past all of that, now we're into the fuzziness, right? So we wanted to go back to the fuzzy matching of all the information that we got back to known lists. So we use different ways, and you can see a couple that I listed there about how we do fuzzy matching into our known lists. And then we have to have this huge decision tree about what do we do? Is it an add, is it an edit? If it's an edit, what do I edit? Is it a person that was at a previous job and now they're at a new job? So we have to figure all that stuff out. And then we have to report what we did. So the outcome. So everyone's like, yeah, okay, cool. We actually ended up avoiding $3.7 million of editorial fees by this automated process. So when you talk to the business units, they're like, that's freaking phenomenal, right? How do I sign myself up for that? We avoided hiring 400 people just by automating this whole process of collecting the data, extracting the information, and putting it all together. And we completely changed the way our editorial process works. Instead of being our internal, push the data in, they're now just looking at it from the backside to say, make sure it's correct, make sure it's right, correct anything that's wrong. So we flipped the way the entire editorial process worked. So you're like, all right, whew, I got through all of it, we're done, we're good to go. Not quite. Not quite. So we have some tooling that we had to build too. So some of our data was really old, and our URLs sucked, honestly, right? So we had to go through a lot of cleanup to make sure the data was good so we can get through processing and scraping all the information. We had some law firms that had the same URL, even though they were different law firms, so we had to clean that stuff up. So you have a lot of cleanup, make sure all your data going in is correct. But we also built tools to say, okay, I have this URL. Is it still valid? Is it still there? Is it being redirected, right? Because I need to know all that stuff before I send it in. So we built a tool to do what we call website checker, just to make sure, is a thing still there? Is it what I expect? And then, we also got into the stats and, getting information back out when the scrapers were done to say, how many pages did it get? How much stuff did it do? How long was it there? And what we then said was, okay, well, we wanted to know, because it's 200,000 websites. There's no way in God's green earth, I'm going to sit there and be able to say, this one now no longer works versus that one's still good. So we wrote alerts to monitor that, to say if a website loses 10% of its pages that it downloaded last time in the last month, alert me. Set up an automatic ticket to the system to make sure that the Zeit team is on it to say, hey, Zeit, looks like this one's got a problem. Do we need to change something? Is there something going on? And of course, sites themselves change and you could get blocked. So you got to be cautious of all that stuff, as you've heard. And then finally, the other tool is that this one has been hitting us hard recently, is that as we have all these URLs in our backlog of stuff, the URLs do change and they become compromised sometimes, and you have to deal with that. So it's not just because of the automation process that's going to have to deal with the compromisation, but it's our editorial team that has to figure out what's going on with these websites. Or if they're finding new websites, is a new website valid? Just because some other system says there's a law firm at this URL doesn't mean that's still true. So we have to be really, really cautious about these compromised sites. And we don't want any kind of virus coming into our network and infecting the entire thing and taking out the entire Alexis. So we're working with a partner right now, urlscan.io, to try to do link validation to make sure, is it malicious, or what is there? And they can give you a screenshot of it back. And we're using some screenshot analysis to say, is it a site that looks like it's for sale, or is it malicious, et cetera. So whatever you guys are doing, if you're doing any kind of URL checks on random URLs that are out there, be very careful. The other thing that we also do is we use an air-gapped machine, a virtual machine, such that if it is a malicious site that they go to, it doesn't matter. We're not going to infect the rest of the network. And that, to us, is critically important. So if you guys are going and hitting a lot of websites and you're not exactly sure, you've got the pile of URLs that you're going to be hitting and scraping, you're not exactly sure what's still out there, make sure you check it and make sure it's safe before you do. So in summary, basically we built this kind of thing, going from the center outwards. And the first thing was we did a lot of preliminary research to see what kind of stuff we were up against. Then we built our core system, and finally we built toolings and alarms around that to help us make sure we had everything correct, to make sure things were running correctly and smoothly, et cetera. And then, things to remember, that if you're doing this, there will be websites that were made in 1990s that are still running and still out there. Some sites will be very sophisticated, some sites will just suck, honestly. You have to define your rules of what you're going to scrape, and if you hit certain things, certain situations, what are you going to do about it? You have to define how your data extraction techniques are going to go. Again, I'd strongly suggest start simple, do the dumbest idea first, make sure you have that working, and then you can start layering on all this additional stuff and all the capabilities. And then finally, just assume websites will change and ultimately will stop working as well. Thank you.
I loved on the screen there where the LLM doesn't know what a fax is. It's just like tiny little score. Yeah. We have probably you have a short, okay, great. Okay, so we'll go for that one. Was there an incident that made you extra cautious? You want to answer that?
Sure, I would love to. Yes, there were. And in fact, over the last month, it's happened 8 times just by URL checking that we've had issues where the person who was investigating the system got a malicious site, got infected, had to get the computer reset and completely redone. And then that's why we started building out this air gap situation.
Okay, so we've time for one more. I'm going to skip to the bottom one there about the entity resolution part, what your solution was for that. Yeah, it's an interesting question.
And it's got many facets to the answer. So for our entity resolution part, we took, again, the easiest approach to start with, which is we know what law firm we're dealing with. We expect that the person already is in our system that way. So if we find the person at the law firm we expect, we know that we've got the right person, and it's just simply updating whatever information may have changed. If it's not, we have to find, do we have a person with the same name elsewhere? And then we use another third-party package to help figure out, okay, well, this person, where have they worked at in their entire work history? And then we use that to say, do I have that person in any of their work history? And say, okay, now I've got the person, I can update them. So that's the short answer to that question.
Brilliant. Okay, thanks so much. Fascinating talk. Thank you.
Thank you.